So, here's another example where you can, just by looking at this data, you're able to see that these various compressors, so each color represents one compressor in a suction group. You can see that these things are banging on and off all the time, many, many cycles per day, over 100 per day. And so just like Trevor was talking about earlier, when a compressor short cycles, it starts by kind of squirting out some of the oil inside of it, and then it takes a few minutes for that oil to get replenished. If you're short cycling, then you're just squirting out oil all the time. You're not giving it enough time to replenish. So ultimately, these compressors are running dry without an adequate amount of oil. And so by basically making the suction pressure control bands, relaxing those a little bit, so that the compressors could, essentially like a dead band, they can run a little bit longer before they end up cycling. And then, changing some other programming on the rack, that enabled us to reduce the number of cycles per day from over 100 per day down to just a few. And so this saves a lot on energy, but it also helps to avoid, again, the oil, getting the oil getting flushed out of the compressor casing. So, these are a couple examples of how data and data analytics and kind of looking at trends in data can be used to identify the root cause of issues that would otherwise kill compressors. And sometimes this could be killing compressors within 24 hours. Other times it might be shortening a lifespan from 15 years to 5 years. But in each case, this is painfully obvious in the data.